This is section 3.2 of MA 104, numbers 9 through 19 odd. For number 9, we're asked to find quite a bit of information about the function f. The first thing that we're asked to find is the domain. If you recall, the domain is just the set of all of the x coordinates. In other words, how does the function span from left to right? Well, if you look, the function starts at this point. If we come from the left, from negative infinity, the function starts at this point, ends at this point. This is the point -4, -3. And this is the point +4, +3. The domain is the set of all the x's. The -4 is included because that point is filled in on the function. The +4 is not, because that point is not filled in. So we use the closed bracket and the open parenthesis, respectively, to show that. For part B, we're asked to find the range, which is how the function spans from down to up. This is the lowest point of the function. This is the highest. So we're looking at the range values, or the y values now. Again, for the range, -3 is included because it's the y-coordinate of the point that's the lowest. But the +3, which is the y-coordinate of the highest point, is not included because it's not filled in. Part C, for the x-intercepts, that's just where the graph crosses the x-axis. The graph crosses the x-axis right here at the point 0, 0. So my x-intercept is 0. For part D, my y-intercept, same idea, the point where the graph crosses the y-axis, which again is at 0. So my y-intercept is also 0. Intervals over which f is increasing. Well, if you were to trace this function, the function is always increasing. It's always moving up over its entire domain. So that means that the function would be increasing from -4 to +4, which is its domain, because it's always increasing. Since it's always increasing, then it's never decreasing and it's never constant. So f and g would each be none, because there's no intervals, or there's no place where this function is decreasing or constant. There's also no points of discontinuity, because I can trace the entire function without ever lifting my pen, so it's continuous the whole way through. We're asked to find the same information for function h. The domain, in this case, would be all real numbers. If you look, the function goes forever to the left and forever to the right. These arrows indicate that that function keeps going. So the domain is all real numbers. The range is the span from down to up. So if I were to start at negative infinity and come up, the very first point that I hit is right here. This is the point -1, -4. The range value there is the y-coordinate, which is -4. So my range starts at -4, and then that function goes up forever. So it would be -4 to positive infinity. For my x-intercepts, the function crosses the x-axis at this point and at this point. To the nearest integers, that would be -3 and +1. So my x-intercepts would be -3 and +1. For point D, the y-intercept, the point where the graph crosses the y-axis, would be right here, which is at -3. So my y-intercept is at -3. The function is increasing. If I look along its domain, when I trace the function, I'm going up, so it's increasing starting at the vertex, starting at this point, and going all the way to positive infinity. So I'm interested in the domain values there. The domain value for that bottom point is the x, which is -1. So it's increasing from -1 to positive infinity. it is decreasing. If I start at negative infinity and come this way, the function is going to be decreasing or going down until I hit this point. So the function is decreasing from negative infinity to negative 1. It's not constant anywhere because there's nowhere in the function where the function is not moving either down or up, where it's not either decreasing or increasing. So the function is always either increasing or decreasing. There's no points of discontinuity because I can trace the entire function without ever lifting my pen. These same ideas for function p. The domain for p starts at negative infinity and comes all the way to this point right here, which this point is the point 2, 1. We'll also need the point 2, negative 1 because that's going to be relevant whenever we talk about this also. But the domain will go from negative infinity and stop, but not include this point. So my domain goes from negative infinity to 2. I'm not going to include the 2. And then I'm going to pick that back up, or I'm going to unite that or union that with everything from this point to positive infinity, because those points all are points on the function as well. So I'm going to union that with everything from positive 2 to positive infinity. The range, if I start at negative infinity and come up, that would go from negative infinity to this point, so negative infinity to negative 1. So the range would go from negative infinity to negative 1. And again, there's that jump. I have to pick it back up again. At positive 1, this time I'm going to include the positive 1 to positive infinity. The reason the positive 1 is included is because there are points of this function that have a y-coordinate of 1. And then the function continues to go up forever. For part C, there are no x-intercepts because the graph does not cross the x-axis at all. For D, the y-intercept, the graph crosses the y-axis at this point right here. That is a positive 1. So the y-intercept would be a positive 1. As far as where f is increasing, or where p rather is increasing, if I trace this, there's nowhere where that graph is going to be increasing. I'm always going to be moving downward. So there's nowhere where the graph is increasing. To find where the graph is decreasing, I would be interested in, when I trace it, where is my pen moving down? If I start at negative infinity from the left, if I start at negative infinity, my pen is moving down from negative infinity until this point. And that point is the point negative 2, 1. So the first part of the interval over which it's decreasing, I'm only interested in the domain. It would be decreasing from negative infinity to negative 2, that's the domain value, and then I'm going to pick that back up where it starts to decrease again, which would be at this point to positive infinity. The domain value here is a positive 2. I'm not including this 2 because 2 is not an element of that domain. So I would unite that with everything from 2 to infinity. Where the graph is constant, let's do that here. Where the graph is constant would be this section right in here. The domain values are negative 2 to positive 2. So it is constant from negative 2 to 2. And then finally, any points of discontinuity, well, you can see that the function is discontinuous right here, because in order to trace it, at this point, I have to pick up my pen and then put it back down. So it's not a continuous function. So that point of discontinuity would be 2. That's the domain value. To find these particular values of the function, what I'm interested in finding are the corresponding y values when the domain values are 4, 0, and 4, negative 4, 0, and 4, respectively. So to find f of negative 4, I find where the function has an x value of negative 4. Here's where x is negative 4. If I come down, this is the point that corresponds to that point on the function. So that is the point negative 4, negative 3, which means that f of negative 4 is equal to negative 3. Similarly, f of 0 is going to equal 0, because if I find where x is 0, y is also 0 there. And then finally, to find f of positive 4, well, this is the point 4, 3. You can see that it's represented with an open circle on this function, which means that it's not actually a point on the function. So in this particular case, f of 4 is undefined. There's no value of y that corresponds to an x value of 4 because of the open circle on that graph. To find these particular values of h, it's the same idea. I'm interested in the y value when h is negative 3, the y value when x is 0, and the y value when x is 2. So to find h of negative 3, when x is negative 3, y is 0, so that tells me that h of negative 3 is equal to 0. To find h of 0, well, when x is 0, y is negative 3, so h of 0 is going to be negative 3. And finally, to find h of 2, when x is 2, y is 5. So h of 2 is equal to 5. Finally, to find p of these particular points, we're interested when x is negative 2, when x is 2, and when x is 5. So to find p of negative 2, I find where x is negative 2 and look for the corresponding point on the graph. So this is the point negative 2, 1, which means that p of negative 2 is equal to 1. P of positive 2, well, if I find positive 2, where x is positive 2, there's no point on this graph that is 2 comma something. The open circles indicate that those points are not actually points on the graph. So p of negative 2 is undefined. And then finally, to find p of 5, here's where x is 5. I look for the corresponding y point. So this is the point 5, comma 1, 2, 3, negative 4. So p of 5 is equal to negative 4.